In this problem, we have a mirror which is given by m prime, or let's call this mirror as m1 m2. Okay, and then we have a person who is standing in front of that. Let's call his top as h, which stands for head, and bottom as f, which stands for foot. And let's say that his eye is somewhere here, and let's call this as e. Now what happens is so for him to fit into the mirror, the ray from his head should reach the top of the mirror, and then it should get reflected and fall onto his eyes. Similarly, his foot should make its image at the bottom of the mirror, and then it should be reflected to the eyes. So here we have this image. Now what I do is I extend this. Now the eye sees as if the rays are coming from behind the mirror. Let's call the top of this as h prime, and then the foot is also coming from this point. Let's call this as, sorry, I'm taking this time because I have to draw the diagram. So let's join this also. Now this becomes f prime, and this is h prime. Okay, now what I do, let's call this distance as z, and since it's an image, even this distance must be equal to z. Now from triangles, triangle em1 m2 and triangle e h prime f prime, so these two are similar triangles, so I can write m1 m2 by h prime f prime is equal to z by 2z. So this is equal to half. So m1 m2 is basically the size of the mirror, and h prime f prime is basically the height of the image, and which is also equal to height of the person. So the size of the mirror must be half of the height of the person. That is the answer.